In this video, we're going to take a look at some of the basic dictionary operations. And for the purpose of this example, we're going to start with this Roman numerals dictionary containing 5 key value pairs, 4 of which are correct. For the Roman numeral I, we have the value 1. For II, we have 2. For 3 I's, we have 3. For V, we have 5. And for X, we purposely put in the incorrect value 100, and we'll modify that momentarily here. So let's go ahead and create that, and let's evaluate the Roman numerals dictionary just so we can see its string representation. Now, of course, one of the things that you'll often want to do with a dictionary is to look up the value that's associated with a specific key. So we can do that using the same square brackets operator that we've used previously to access individual elements in a string, list, or tuple. In a string, we provide an index number and it gives us back the corresponding character at that position. In a list or a tuple, we give an index number and it gives us back the corresponding element at that position. And in all 3 of those index numbers are integers that are starting at the value 0. In the case of a dictionary, when we use the square brackets operator, we provide not an index number, but rather the key that we would like to look up and get the associated value for. So if I go ahead and do that here, we can see that V has the corresponding numerical value 5, which is of course what we had placed into the dictionary in the first place. Now, we also can update values in a dictionary. Dictionaries are mutable entities, so let's go now and fix the value associated with X. So up here we said X was 100. We know that's incorrect, so let's assign it the value 10. So when you use an indexed dictionary expression on the left side of an assignment, it looks up that key and replaces the corresponding value. And so we can now go ahead and see that we were able to modify the dictionary and update the incorrect value. If the key does not exist, an expression like what we showed you up here will actually add a new key value to the pair to the dictionary. So let's go ahead and do that. Let's put the value 50 into the key L. So we're now adding a new key value pair. As long as this value is unique and is on the left side of an assignment, we're going to create a new key value pair. So once again, we can evaluate Roman numerals, and a couple of things I'd like you to notice. Number 1, there's the new key value pair, but number 2, notice that it's at the end of the string representation of this dictionary. Again, starting with Python 3.7 and higher, the dictionaries are maintained in the order that you add their keys to the dictionary. So because this was the last key value pair added, L shows up last in the comma-separated list of key value pairs. So at this point, we've demonstrated creating a dictionary, accessing its elements both to see them and update them, adding a key value pair. Now let's talk about removing a key value pair. So for this purpose, let's go ahead and use the del statement, which we've shown you previously. When you say del followed by an indexed dictionary, it's going to remove that element from the dictionary. So for example, if we want to remove 3 from the dictionary, this is going to remove the entire key value pair. Now we can go and evaluate Roman numerals, and we have 1, 2, 5. Notice that the key value pair for 3 has in fact been removed. Now there's also a pop method that you can use to remove an item. So let's just demonstrate that. We saw pop with lists previously. If you give pop a given key, it will remove that key value pair from the dictionary. So let's remove the value for X. Notice it returns the value that was associated with that key as you remove the key value pair. It doesn't return the key because you already knew what the key was when you called pop in the first place. And of course, if we now evaluate, we can see that X no longer is in that dictionary. Now, you might be wondering what happens if you try to access a non-existent key within the dictionary. So let's go back and try to access the value associated with the key III, which we removed previously. When you do that, you are going to get an exception. A key error is the type of the exception. It tells you what the key was you were looking for, and this is an indication that the key is not in the dictionary. Now, in some cases, you may not want to have to deal with exception handling when you're looking up a given key. So for that case, they actually provide a get method on dictionaries, which can be used a couple of different ways. So first, let's show you what happens if we call Roman numerals.get and give it the argument III. And you'll notice I don't get an exception and I don't get a result. If you call get with a key and there is no corresponding key value pair in the dictionary, get returns the Python constant none, and IPython displays nothing for that constant. So that's why we didn't get an outline in our interactive session here. Now, sometimes you may want get to return a different value if it can't find the corresponding key. So let me go ahead and recall that, and let's say we want to have it return a message like III not in dictionary. So this it doesn't have to be a string necessarily. You can have it return any value you want, but in this case, because this key is not in the dictionary, this string is going to be returned when I execute this call. So now you can see we get that string as the result. Now, if in fact you use get with something that is in the dictionary, so for example, if we look up above here, we still have 5 in the dictionary, so let's use V, you will get the corresponding value in that case. Now, the last thing I'd like to take a look at in this particular video is the in and not in operators. Sometimes you simply want to know whether a dictionary contains a given key or not. So for example, we can say V in Roman numerals as a condition, and we could use this, for example, in an if statement if we wanted to. Here we're just evaluating the condition. So we know that V is in the dictionary. We can see it up above here, and we can also see that we got the value previously. In this case, we get true because the key is indeed in the dictionary. If I recall that and replace V with a key that's not in the dictionary, we of course get false. And as you would expect, the not in operator returns the opposite of the in operator. So if I recall that previous statement or expression, I should say, and make it the not in operator rather than the in operator, of course this key is not in the dictionary, so when I execute that, I get true.